Hi, good morning, everyone. So till now, we have saw the valency, right? So valency already I have explained it. So valency is nothing but the bond formation ability of any element or any chemical species, we can say, right? Or any chemical compound. So the number of electron present in the valence cell undergo into the reaction. I mean, they are the very important part of any element, right? So why? Because the electron present in the valence cell, they only, involved in the formation of bonds. So that's why from first year to second year, we just study about the valence cell, except d orbitals. I mean, transition elements. Later, in the second year, we see some extra, different chemistry in case of D block elements. And those D block elements are also called as transition elements, where not only the valence cell electron undergo into the formation of bond, even the cell which is present. Just I will remind. I will give a hint. Not only so, if I say just valence cell only undergo into the formation of bond, means this statement will be wrong in case of what transition elements. D block elements. So this is called valence cell or outermost cell, and the cell which is just present inside the valence cell, outer cell. This is called penultimate cell, right? So these concepts will come penultimate cell in your second year, right? So penultimate here in D block elements, not only the valence cell electron involved in the formation of bond, penultimate cell electron also involved in the formation of bond. This is the different case we will see whenever we come across with the D block elements. Then definitely we will study in brief, right? So penultimate cell and the valence cell electron involved. So that's why these are called as a transition elements, right? So the D block elements. But now for our first year, we will just see the elements of S and P block, right? So in S and P block, for S and P block elements, one we can say the valence cell electron only involved in the formation of bond. So that's why the charge, positive or negative charge, whatever charge we get on the small elements like sodium, calcium, they are just single. For sodium, what we can say is always it show +1 plus only, not 1 plus in some other case +2. No, this will not show. Why? Because only valence cell electrons are involving in such type of elements. So that's why directly for S and P block, what we can say is only the valence cell electron. The electron present in the outermost cell, they only involve in the formation of bonds. So that's why we see only the single charge always onto any element. So in that regard, we have saw some different element, how they get a positive and negative charge. So that's why, so again I will repeat the class. Here carbon, nitrogen, oxygen and fluorine, from till here there was a positive, +4 charge we see on the carbon. Definitely, that's why the carbon, what happens around the carbon, there are 4 bonds. But now moving from carbon to just next element in the period, that is nitrogen, here the positive becomes directly negative. Why? Because the electronegativity now coming into the existence. Because of electronegativity, why that electronegativity is coming means, as we move from directly from carbon to nitrogen, so nitrogen electronic configuration is very important, right? So electronic configuration is 1s2, 2s2, 2p3. Directly going to this concept, I will just make you, I will take your attention towards what means when the molecule or an atom or a element will be stable. So element or a molecule will be stable in two cases, right? Very important this is. The orbital. So based on the orbital only we decide whether the element is stable or not. If a element is having completely fulfilled orbits with the electron like this, fulfilled, then also it is very stable. And when the orbital is having the unpaired electrons, if all the orbitals are having unpaired electrons, then also it is very stable, right? So here see, when it is completely filled, stable. When it is completely half filled, then also it is stable. If this is the case, if two are half filled and one is completely vacant or empty, means the molecule will not be stable, right? So when the molecule will be stable, when if the electrons are present, okay, they should be half filled or else they should be fulfilled. Fulfilled and half filled orbitals are most stable. This part comes very importantly in case of what, nitrogen. And in case of p block elements, what we see is always inert pair effect. Just in the last class only I have explained, inert pair electron is inert pair effect is nothing but, even though, I mean, see, according to my statement, all the elements should involve in the formation of bond. But in case of nitrogen, it is not happening. Why? Because see, inert pair effect is coming into the existence. Now this is the inner cell and this is the outermost cell. So these outermost cell electrons, I mean 5 electrons are present in the outermost cell. That means what they need to do, they should involve in the formation of bond. But this is not happening. Why? Because inert pair effect will come into the existence. Inert pair effect means, again I remind you, even S, and this inert pair effect only belongs to what? S block electrons, and I mean S orbital electrons. The electrons present in the S orbital, I mean, even though they are present in the valence shell, they won't go for the formation of bond. Why? Because see, with respect to P, in case of nitrogen, with respect to P orbital, they are completely infilled, I mean half filled. Half filled are more stable, first case. With respect to S orbit, they are completely filled. That means again they are stable. So that's why these two electrons will not involve in the formation of bond. Why? Because of this case, right? They are very, very stable. So that's why this electron, I mean nitrogen, is showing -3 charge on it. Why? Because even though these 3 electrons are present in the outermost, I mean in the valence shell, right? There are 5, but with respect to P, there are 3 electrons, and these 3 electrons, this nitrogen is not allowing to donate. Why? Because its size. What is its size? Size is very less. Due to the less size, nucleus is very near. Because of nucleus is very near, these electrons are not easily, I mean, removing. I mean, ionization is not taking place very easily in case of what? Nitrogen. So that's why from carbon to just next element, the negative charge comes. And now coming to this oxygen, we have stopped our class in last class here itself. But now in case of oxygen, see, now it is unstable actually, but only 2 half-filled orbital, and half-filled orbital only involved in the formation of hybridization. We will go next class for the hybridization, right? After knowing these, one we can directly go into the what? Hybridization, right? And now, because of these 2 half-filled orbital, these 2 half-filled orbital only involved in the formation of bond. And that too, again, the size is now, as I compare the size of oxygen to the nitrogen, size is very less. So now, because of that, these 2 electron will remain onto the oxygen. So that's why it will show -2 character. And coming to fluorine, we already know about the fluorine. fluorine is most electronegative element present in the periodic table. And why? Because it is having a very less size. So that's why only one half filled orbital remain in case of fluorine. So that's why fluorine always shows a one negative character, right? So you can directly see these things will not come very easily. You have to try it, right? I have given a hint. You can go for different cases. I mean, you go for calcium. This is a second block element. I mean, second group elements. So that's why they show +2 charge. And coming to aluminium, it shows +3 charge. Why? Because third group element these are, and they are having always 3 electrons in the outermost cell. So that's why they show I mean, they make their electron for the bond formation. So that's why these elements can show +3 charge. I mean, aluminium. And coming to second group, they always and the elements which are present in the second group, you can take calcium, magnesium, right, strontium, barium, Ba+2. So those all can show +2 charge. And in third group, coming to third group, there are only 3 electrons present in the valence shell. So that's why the elements which are present in the third group, they always show +3 charge. And some of the cases are there. I mean, cyanide, sulfate. These we have to remember, right? So all the things will not be explained by in chemistry. Some of the cases are there. In case of OH, always there will be a minus charge. I'm just showing you. You try it, you go through the periodic table and you check the valency. And for sulfate, always -2 charge. On cyanide, always minus charge. So these are the exceptional cases we have to remember, right? So these things will not be shown in case of what periodic table. So some of the exceptional cases are also there. You just go and try it and try to send me. Today's your assignment is try to send the element and their charge on them. On what lithium there is +1 charge, right? Understood? On sodium there will be +1 charge. You just go through the periodic table and books. You try to find minimum 15 elements with their charge, and you just calculate with their electronic configuration, and you also experimentally check it. Why +2 charge is there? Why -1 is there? Why right? So you just check and you send me minimum 15 element. Element symbol with their charge. Right? With this, we will conclude. In the next class, we will see the next part of our chemistry, right?